In this video we will discuss basic topics of fractions. Those 5 basic topics will be the meaning of a fraction, equivalent fractions, reducing fractions to lowest terms, improper fractions, and plotting fractions on a number line. First, let's start with the meaning of a fraction. It's really important that we understand that fractions are representing a number of equal parts of a whole. Fractions are made up of 2 parts, a numerator and a denominator. The numerator is what goes on top of a fraction, and the denominator is the number that's on the bottom of the fraction. The denominator actually represents the number of equal parts that the whole is divided into. How many equal parts are in this circle? In this circle we see that we have 8 equal parts. We have 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So our denominator will be 8. The numerator represents the number of equal parts shaded out of the whole. So let's say, for example, that I would like to shade 3 of these parts. This would be like if you had a pizza cut into 8 equal parts and you wanted to eat 3 of them. So let's say that I ate these 3 pieces. That would represent the fraction 3/8. Equivalent fractions. Many fractions that we use are actually equivalent and can be said in many different ways. For example, let's say that I have a circle that's cut into different number of pieces. The first one is cut up into 5 pieces. What would be my denominator for this first circle? That would be 5. Let's say that I decide to shade all 5 pieces of the circle. That would be 5 out of 5. The next circle, what would be my denominator for that? Well, that would be 8. There's 8 equal parts. And let's say once again I decide to shade all 8 pieces. This would be like our pizza, and that I eat all 8 pieces of that pizza. What would be the denominator of my third circle? See, it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 equal pieces. And let's say once again that I eat all 12 pieces of this pizza. So I'm going to shade all 12. Well, if we notice something about all of these, if I cut my pizza into 5 pieces and I eat all 5, or if I cut my pizza into 8 pieces and I eat all 8, or 12 pieces and I eat all 12, how many pizzas have I eaten? Well, it turns out that all of these are actually equivalent fractions representing the same value. They represent one whole. So all of these fractions actually would reduce to 1. We also could think of it as 5 divided by 5 is 1. 8 divided by itself, 8 divided by 8 is 1. 12 divided by 12 is 1. All of these represent exactly the same thing. They're all equivalent fractions representing one whole. Let's form a few other equivalent fractions. Let's say that I decide to shade one of these 3 pieces. That would be 1/3. What would be an equivalent fraction to 1/3? If I have 6 pieces in this circle, how many would I have to shade to be equivalent to the 1/3? Well, I would have to shade 1, 2 of these, and we notice something. We notice that 1/3 and 2/6 are exactly the same amount. So 1/3 and 2/6 will be equivalent fractions. It's the same value, but just represented in two different ways in the form of 1/3 and 2/6. But both of those would be exactly the same value. 1/3, we would call this the reduced version of that value. This will be the reduced fraction. And let's look at our second circle, or our next circle over here. We have 4 equal pieces, so my denominator will be 4. How many pieces will I shade? Let's see, let's shade 3 pieces. So this fraction would represent 3/4. So I've shaded 3/4 of this original circle. Now let's look at this one down here. We have 12 equal pieces, so my denominator will be 12. How many of them would I have to shade to be the same value as 3/4? So I'd shade 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like I would have to shade 9 of those 12 pieces to represent the same value as 3/4. We can see that both of them have the same exact portion shaded. Just one has more pieces than the other. The top number up here, the top fraction, would be considered to be the reduced version of those two values. So we know what equivalent fractions are. How do I create my own equivalent fractions? This is something that we will do often. If I want to create an equivalent fraction, what I want to do is I want to multiply by 1. If I multiply something by 1, I think we could agree that 2/5 times 1, anything multiplied by 1 would be basically the same thing, 2 over 5, 2/5. But I don't want to multiply by 1 because that doesn't change anything. What I want to do is multiply by 1, but in a kind of a sneaky way. So let's get rid of this. We just talked about that 2 over 2, 2 divided by 2 would be the same thing as 1. And if I multiply by 1, it doesn't change the value. So if I multiply by 2 over 2, which is an equivalent value to 1, then the value of the fraction won't change. Multiply top times the top and bottom times the bottom. Sorry, that would be 10. And now we have what we call an equivalent fraction to 2/5. So 2/5 and 4/10 would represent exactly the same value. Let's create another equivalent fraction. I can multiply the top and the bottom by 3. Then I create equivalent fraction 6 over 15. So it's 2/5 and 6 over 15 have exactly the same value. If I was to take two circles and divide one into 5 pieces and shade 2 parts, and divide the other circle into 15 pieces and shade 6 parts, they would represent exactly the same value. I could multiply top and the bottom by 4. Another sneaky way of multiplying by 1. We get an equivalent fraction 8 over 20. We can keep going like this. I could multiply by 5 over 5. Created another equivalent fraction, 10 over 25. And then I could also multiply by any number that I want to. So let's say this time I decide to multiply top and the bottom by 12. As long as I multiply top and the bottom by the same value, we're multiplying by a 1, we don't change the value of the equivalent fractions. 2 times 12 is 24. 5 times 12 is 60. So all of these are equivalent fractions to 2/5. What we want to do is always reduce our fractions to lowest terms. We see that there are many equivalent fractions that we could have, but we want the fraction that represents all of those equivalent fractions that's reduced to lowest terms. How do we reduce a fraction to lowest terms? We want to find an equivalent fraction that has no common factors between the numerator and the denominator. We're going to factor the numerator and denominator into prime factors, and then we want to divide out any common factors. So let's look at this first fraction, 14 over 21. We want to find an equivalent fraction to 14 over 21 that has no common factors in the top and the bottom. 14, we can always use our factor tree to break up 14. That would be 2 times 7. And 21, 3 times 7. Once again, we have that 7 divided by 7, and what did we say 7 divided by 7 was equivalent to? That's equivalent to 1. So now we have 2/3, and 2/3 and 14 over 21 are equivalent fractions, but 2/3 would be the fraction that is reduced to lowest terms. Okay, what about -4 divided by 16, or -4/16? This is not reduced. We know that 4 would be 2 and 2. 16 would be 2 times 2 times 2 times 2. Break that up into all its prime factors. Well, once again, 2 divided by 2, we know that's 1. We have another 2 divided by 2 that gives us 1. We have nothing left on the top, so we'll put 1 in as a placeholder. So our final equivalent reduced fraction would be -1 divided by 4, or -1/4. These have an equivalent value, but -1/4 is the reduced form of that value of fractions. $30 divided by 6. Let's reduce this fraction. 30 broken up into prime factors. 30, let's think of it as 2 times 15. Keep the 2 since it's prime. 15 will be 3 times 5. So we will keep the 3 and the 5. So the top is 2 times 3 times 5. And 6, hopefully we know that 6 would be 2 times 3. Do we have any common factors in the top and the bottom? 2 divided by 2 is 1. 3 divided by 3 is 1, so we were left with 5 over 1. Now 5 divided by 1 is just 5 itself. So we can reduce that to an equivalent version of just 5. We always want to reduce our fractions to lowest terms. What about improper fractions? Improper fractions are fractions that represent more than just one whole. When the numerator is larger than the denominator, we call that an improper fraction. Say we call that an improper fraction. An improper fraction can also be written as a mixed number. Say that we have 23 divided by 6. 6 still represents the number of equal parts for each whole. So we have each one of our circles here is broken up into 6 equal parts, but this time we are asked to shade 23 of those 6 equal parts. So we have 6, so here's 6, here's 6 more, we need 23, so far we have 12, we need another 6, so far we have 18 shaded, 19, 20, 21, 22, and 23. So how many whole circles have I shaded? We've shaded 3 whole circles. And then how much do I have left over here? Well, here I have 1 piece left over, so we've actually only shaded 5 out of 6 circles. So we would say that we have 3 and 5/6. What's another way that I could come up with 3 and 5/6 without actually drawing all the circles and shading the equal pieces? Well, another way that you can do this is to say 6 goes into 23. How many times? Well, it goes into there 3 whole times. 3 times 6 is 18. And what's the remainder? Well, the remainder would be 5. We would say that we have 3 whole circles and then 5 as the remaining pieces that did not completely fill another circle. So that would be 3, 5 out of 6 remain. I want to shade the portion of the circles that represents 29 divided by 9. And we want to write our final answer as a mixed number. Well, we have each one of these circles is broken up into 9 equal parts, and we need to shade 29 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 pieces. We can shade all of these. That represents another 9 pieces. We have 18 so far. We can represent another circle here, another 9 pieces. 9 plus 9 plus 9 is 27, 28, 29. So what would this be as a mixed number? That would be 3 wholes and 2 were shaded out of the 9 equal pieces. Remember that another way that I could do this is to say 9 goes into 29. How many times? That would be 3. That gives me 27. And then I have a remainder of 2. So that would be 3 wholes and then 2 out of 9 remain. The last thing we want to talk about here is plotting values or fractions on a number line. Remember that the denominator still represents the number of equal pieces. So let's say that we have 0 here, and 1 here, 2 here, -1 there. 2/5. That means that we have a value. Notice that the top is not larger than the bottom. It's 2 out of 5. That is not 1 whole. So we're going to be in between 0 and 1. How many equal pieces do I need? Well, I need 1, 2, 3, 4, 5 equal pieces. And how many of them do I need to shade? Well, I need to shade 2 of them. So what we really do is we start at 0 and we actually skip 1 and we go to 2. So we have gone 2 spaces. So we would say that this line right here would represent 2/5. It's 2/5 of the way between 0 and 1. So the denominator tells you how many spaces to break up in between the whole numbers, how many equal pieces that we need, and the top number tells you how many of those to move to the left or to the right. Okay, what about 11 divided by 4? Now this time our numerator is larger than our denominator. We have an improper fraction. So let's call this 0, and then 1, 2, we have 4 equal spaces in between each. 1, 2, 3, 4. 1, 2, 3, 4. And this will be like our -1. So you're asked to go 11 equal pieces of 4. So we broke in between 0 and 1, in between each of my whole numbers, we have 4 equal pieces. We want to go 11 of those 4 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That puts us right here. So 11 over 4, we'll be breaking up 4 spaces in between each of the whole numbers, and then we want to go 11 of those. What's another way that I could refer to 11 over 4? Well, we could write it as a mixed number. 4 goes into 11 2 times. 2 times 4 is 8, the remainder of 3, so this will be the same thing as 2 3/4. Notice that if I write it as a mixed number, it's really easy to graph because I could just go 1, 2, and then 3 of the 4 equal pieces in between 2 and 3. What if my number is negative? Negative means that I need to go in the opposite direction. So let's call this 0. And then how many equal pieces do I need between each of my numbers? Well, it looks like my denominator is 8, so I need 1, 2, 3, 4, 5, 6, 7, 8 equal pieces between my numbers. Notice that my denominator is larger than my numerator. So I need to go 5 of those 8 equal pieces. Since I'm negative, that means I'm going toward the left. So we go 1, 2, 3, 4, 5, and that gives me negative 5/8. So we have this broken up into 8 equal pieces, and we go 5 of those 8 equal pieces. Since we're negative, we're going toward the left. And our last one, it is a negative value, so that tells us that we are going toward the left of 0. So let's put our 0 here. And then how many equal pieces do we need between our numbers? Well, our denominator is 5, so we need to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think that's good enough here. And so we have 5 equal pieces between each of our whole numbers. Now how many of those pieces do we need to go? We need to go 14. So let's start at 0 and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we need to go 14 units in the left-hand direction. So that gives us negative 14 over 5. What's another way that we could have done this? Well, we could have converted this to a mixed number. 5 goes into 14. How many times? Well, that would be 2 times. 2 times 5 is 10. Remainder of 4. So that would be 2 and 4/5. And it's negative. So this value could be written as a mixed number or as an improper fraction. But either way that you do it, if you do it as a mixed number, you would go to -2 and then keep going toward the left 4 of those 5 equal spaces.